Okay, hello class. In these sessions, let's study about structure and then learn class, which is a very important concept in C++ in the following sessions. So let's begin. Structure is similar to array in terms of storing a set of data or grouping different types of data. In array stores a set of data of the same types at continuous memory locations, so arrays are homogeneous collections. On the other hand, structure is a heterogeneous collections because it could store different types of data. And in order to use structure, you must first define structure with the struct keyword. This is like you are defining new data type. And typically we define structure globally. So when you are defining structure like a global variable, it does not take up the memory. It is just placeholder which tells how structure looks like. Below is the concrete example of the structure definitions. The keyword struct indicates that this is the structure type of definitions. And here CD account v1 is the name of the structure type. We call this structure tag. So CD account v1 is a structure tag. And even though C++ does not enforce it, the structure tag usually start with uppercase letter. This structure stores 3 data, 2 double type and 1 int type of data. And they are called member name. And the structure ends with semicolon like this. Structure type can be just like other data type. Since we have defined the structure CD account v1 globally in previous slides, we can declare the variable with CD account v1 type like this. Account is a variable of type CD account v1, which is structure type we defined in the previous slide. And these statements create an instance of the structure. Note that you can also use structure in C, but when you declare structure in C, you have to explicitly specify struct keyword like this. But in C++, this struct keyword is optional. So CD account v1 has 3 members, as we saw in previous slides. Then how can you access these 3 members? You can use a dot operator with the structure variable. So like this example, you put the structure variable name and followed by the dot and then the member name. With this, you can access structure members and we call this member variable. So these 3 are all member variables. And 2 different structures can have a same name of member name. We can declare same name of the identifier. So we cannot declare same name of the identifier, but we can have same name of member names. So here we have 2 member name with the same name balance, but this is syntactically correct. We can put the same name. We can give same name for the 2 different member names if they are in the different structures. So here, because balance, these 2 member name has a same, because they are in different structure. One is in CD account v1 and the another one is in CD account v2. So this is a syntactically correct in C++. This is because even they have the same name of the members, C++ can distinguish them because they eventually will have different member variables like this. So if you look at here, we have account 1 and account 2. Variable account 1 is a type CD account v1 and account 2 is a type CD account v2. And the first one, this one, is accessing the balance members in account v1, and this one accessing balance in account v2. We can differentiate these two even though these two have the same name because of this variable name is different. So this is the reason why we can have a same name for the member names if they are in the different structures. And when you are defining structure, you have to put semicolon after final brace here. There's a reason for this strange syntax. You can put structure variable name between this final brace and the semicolon. You can put the variable name here. So with this, developers can define structure and declare the structure variable at the same time. Okay, let's look at the demo code for this structure. So this is the code. If I compile this code and run it, this program produces this output. If we look at this program has a two structure. One is a CD account v1 and another one is a CD account v2. And as you can see here, it has three members. And here we are also declaring the account 2 variable for this CD account v2 structure. And here we are declaring the account 1 variable, which is a type CD account v1. So in C++, this is fine, but in C, you also have to explicitly put struct keyword when you are declaring the structure variable. And here we are using a dot operator to access the members of this CD account v1. So here we set the balance to 1000 and terms to 2 and interest rate to 0.02. Here we are printing this balance, account 1's balance. So this one produces this output. And here it prints 2 here, year 2, because we set 2 here. And becomes this number is from this one. It prints here. Same for account 2, which is declared here. We set the members and print here. So this is how you define structure and declare the structure variable like this or this, and then access the members in the structure using a dot operator. This is how you use a structure. Go back to the slides. The structure type can be used as function argument as well. So function can have call by value parameters or call by reference parameters or combinations for the structure type argument. And if the size of the structure is large, it is recommended to use call by reference in order to avoid redundant copy of the data. Call by reference passes the memory address, as we learned in previous weeks, where it passes the memory address where the data is stored. So no data is redundantly copied if we use the call by reference. And structure type can also be the return type of the functions. So if we look at here, this is the function declarations. It received one argument type structure, cd account v1 structure, and it also returns the structure, the cd account v1. So let's look at the demo code for this function argument for structure. And if I compile this program, if I run it, this program produces this output. So if we quickly look at this code, there is a structure definition here. It has a structure named cd account v1. It has a 3 member variables. And inside of this main function, we declare the structure variable ACC, and we are setting the members using a dot operator like this. And then we pass this structure variable to this print account info functions. This print account info function receives the structure types of arguments, the cd account v1, and inside of this function, it accesses the structure members to print this output. So like this, you can pass the structure variable to the functions. And inside of the function, you can use the members in the structure. Okay, so let's go back to the slides. You can initialize a structure when you are declaring it. So if you look at here, we are declaring due date variable, which is a type date structure. And at the same time, we are initializing this structure. And the order of initializing values are important. The first initialized values will be stored into the first member variable, and the second initialized value will be stored into the second member variable, and so on. So order is very important. And the number of initialized values are also important. It is compiler error if you put more initialized value than the structure member variable. So if you put 4 values here, the compiler will throw error because there is only 3 members in data structure. But it is okay to initialize fewer values than the structure members. So if you provide fewer values, the provided values are used to initialize member variables in order, and the remaining member variables will be initialized to default values, which is normally 0. So it's okay to put 2 values here. That's syntactically correct. And you can explicitly provide default value of member variable when you are defining the structure. So for example, here, the default value of month is 12, and day is 31, and year is 2003. This can only apply to non-static members. And it is new features, which is included in C++11. So if you compile this code with C++98, warning or compiler error will occur. So like this, if we compile this, this -std indicates the compiler version. So if we put C++98, the warning will occur here because this setting the default value of the structure member are newly introduced in C++11. So let's look at the demo code for this one to see whether compiler actually prints the warning or compiler errors. So this one. So like the code we saw in the slides, we are setting the default value for these members. So let's compile this program with the older version of the compiler, C++98, to see whether the compiler throws error message or warnings. File name is struct init. Okay, so as you can see here, the compiler throws warnings like this. Here, saying that it's C++ 11 extensions. So if we put 11 here, there's no warning here. Okay, so let's go back to the slide. Okay, that's it for the structure. We quickly review the structure and some of the differences between C and C++. In the following session, we will talk about the class, which is a very important concept in OP. Okay, see you in the following sessions.